Gotta click the go live button if you want to actually send the data stream to the internet. I think we're good now. Yeah. Cool. GitHub, Bevy, pull requests. Recently closed. Render world, render systems. I think this is, yeah, it's capturing audio. Cool. Replace the render graph with systems. So, render graph is gone. This is a really cool change that went in this week. This is a 0.19 change, so it won't have any effect on the jam or anything like that. But it does make me already like, I like the change. We'll put it. These are a couple of things that are in the weed. Contact system buffers, yada yada. Hey Prince, how are you? Forgot to fill up my water bottle again. So the render graph is gone. If you didn't know what the render graph was, you never have to learn about it. If you do know what the render graph was, then you'll be happy to know that it is gone, and also that basically what the render graph was doing has now been moved to schedules and how schedules work, which is a really cool change because it means that any like ECS scheduling improvements now also benefit like the scheduling of that render graph that used to exist. Hey Richard, how's it going? Thriving and also without my water in my bottle. Yes. Yes. The only addendum to that is whether you're at 2 or 3% on your phone. So this is a huge PR. We're not really going to go through the PR. The probably best option, because I assume that most people don't really know what the render graph is. Probably best option is to take a look at some of the shader advanced examples. Because the game of life might be a decent one. The things that aren't going to like change per se are the way you define and use like the high level APIs. So like the material APIs, the standard material APIs, those don't have any changes. This is more of a like, if you were writing your own pipelines, if you were doing some more advanced stuff with shaders, if you had a custom post process, or if you're doing compute, those things have a little bit of change. You're so glad the render graph is gone? Nice. 81%. Yeah, I guess you're a little bit more your way through your day than I am. So I think this one is it's not a great perfect example because I guess most people aren't really doing compute per se, but it's a decent demo of what this looks like. So effectively that render graph doesn't really exist, and there's a new thing called a render graph that is just like a schedule. So we've got render startup and some other like life cycle stuff. And where you would normal have like impl a node. So if you go to Bevy right now, there's node and view node. And not the, how do I frame this? Not the UI node. This is a different node. This is the render graph node. Which unfortunately doesn't really have a great, let's see which one of these is going to be reasonable to look at. Let's look at downsampling. Let's get a shadow pass. Not super interesting, actually. Camera drivers run the graph. So it used to be camera driven rendering runs the graph, so to speak. Um, Terrible to find an example now that this, I can go to the actual repo and check the 0.18 branch instead. Now that the change has actually been made already, stuff on main is now only the new stuff. So if we go to shaders advanced here, then if we go to compute mesh didn't make it in. So let's look at which one is going to be good. Phase item. This is going to be view node though, I think. No, this isn't going to be view node. View node is render phase. So you used to have to do this. This is, make your draw node, make a label, use the label to schedule things in the render graph. That's more at the top of the file. Inside of this view node, there's like a view query where you can like query some stuff from the render world. You get your extracted camera, view, target, whatever, like the textures that you can render to. And then there's this like run function where you got the graph, you got the render context, you got like the query that you typed up here, and then access to the world. So you ended up doing like a lot of world get resource, world get this, world get that, world do these things. But then here you just get access to like effectively just WGPU. Bevy has some like, I'm going to call them like low level APIs, but low level where they are effectively WGPU, but mirrored into Bevy. So in WGPU, if you build like a render pass descriptor or something like that, and you pass in a fragment state, you'll pass in a shader that is a compiled shader module. But in Bevy, you'll pass in like a handle to a shader. So very small differences, but just like that one level of raw WGPU to like Bevy APIs. But what you do in this run function is basically just like set up your render pass and run it. There's some high level APIs like begin tracked render pass and stuff like that, but that's TLDR. In this run function, you can do really whatever you want. You can get direct access to WGPU and do stuff. Was the rationale that it was a redundant impl since both are graphs? I think that there were original reasons to do the render graph. Scheduling has vastly improved since the render graph was originally implemented. And thus, due to the evolution of scheduling getting better and better and better, and whatnot, basically scheduling does everything that the current render graph needs it to do. And some of the theoretical gains you could get from the render graph haven't necessarily manifested, or nobody's put the work in to like actually do them. And with the switch, so going from render graph to scheduling, those things are still kind of within reach. So that's like the TLDR. Basically, like the render graph existed for a long time. Scheduling got much better, especially with schedule lists and stuff like that over the years. So now scheduling is very, very good. And it would be nice if that render graph like also could benefit from those scheduling improvements that are happening all the time, rather than being like a separate thing for like how do you schedule stuff. So previous world, you had to implement either view node or node are really the two traits. But they both give you this run function where you get the render context. You can access as deep down to raw WGPU as you want. I use this currently for mesh shaders stuff. If you've seen some of my posts on, I guess, I don't know what to call them on YouTube posts, YouTube text posts, I don't know. I've shared some of the progress on mesh shaders there. That's going to go into a video at some point. But that's all like very low level WGPU stuff where I'm passing in like compiled shader modules and stuff into that. That's all happening in this run function right now. So what was that? That was the custom render phase. Let's take a look at the custom render phase again. Over on main, if we scroll all the way up on the old version, you end up with a lot of imports, but also this section of code here. And we need to basically, like, as part of what we're doing here, take our view node that we've implemented, or node, or whatever it is, take that label that we defined, place it into the core 3D, like subgraph, and then pass it into the main opaque pass. So custom APIs, this used to be like petgraph or something like that. I think we got rid of petgraph a while ago. New world is much nicer. New world is core 3D is now a schedule, and you can just schedule things against the rest of the systems in the schedule. So what you end up with here in the new world is add it to the core 3D schedule. This is our system. This is going to be the like impl view node replacement. And this runs after the main opaque path 3D, which is an import. So this just comes from the core pipeline, right? Some function. After this system in the main path set. So this is significantly better in my opinion. Much nicer. Very happy about that. I don't know how many people in chat right now are like familiar with the render graph, so I'm just kind of like glossing over stuff. But if anybody actually has questions, feel free to bring those up. So if we scroll down, then we end up with a custom draw system, right? So you can see that view query that we had in the impl view node. This also takes access to world, although it doesn't need to now. I think some of these take access to world because it's easier to port. Actually, no, stencil phase render takes world, so we actually need it here. But if you are accessing resources, if you're accessing anything else, that can go up here. So like, for example, here's stencil phase. It's a resource of view sorted render phases, right? So in the compute mesh, for example, what the compute mesh example is doing is generating a bunch of, or not a bunch, but generating like a cube on the GPU in a compute shader. So there's this function that would have been our impl that we need to run before the camera. And in our render graph schedule, we basically say, add this. So if we go down to compute mesh, this is our system. This used to be our impl, right? So we get the render context, we get some custom resources that we have in the render world, we get the mesh allocator and things like that. So everything that you're used to with systems and params and things that you would expect to be able to access in those systems are just ready here in the same APIs, which is really nice. There's no like custom view node API anymore. Does that make sense to people? And then you get to do like whatever you want down here, right? So in this case, we begin a compute pass, we do our stuff with our compute pass, and then we're just like done at the end of the function. I guess if you haven't worked with the render graph, it may not be clear as to why this is so exciting. But the thing I would emphasize is I think this makes it more approachable to learn about what rendering is actually doing, because there isn't really like a custom implementation of system running anymore. It's just all schedules and systems, and you can dot chain things, you can dot before and after things, you can put things in sets, etc. Just curiosity, does the render graph get executed once per frame, once per pass? The render graph effectively gets executed once per frame is what I would say. The way that it works on a high level is kind of like each camera has its own subgraph, and thus the camera will drive that subgraph. So I think theoretically, you could cause it to do multiple if you were really trying to. But in general, I think of it as like a single run. So I've got like typical Bevy examples that I've been updating. And we're just going to make a couple of changes here. Just get rid of a bunch of these open files. Layer material is going to probably take me a second, but let's do edge detection. I think the dissolve probably has the same changes though. So they're like literally the same changes we just saw. So if we go into the edge detection, which is the one I want to update, there is main, lib, and post process. So I've got these 3 files here. The things that don't exist anymore are core 3D and render graph, right? So examples, edge detection, custom phase, source lib. Let's go to lib. Let's go to the top of the file because we'll see the errors. Again, tons of imports here. I guess we won't see the files. Why don't we see the errors? Rust Analyzer not running. 4 and 44. So this should be gone. Let me restart Rust Analyzer. The graph should be gone here, and then the render graph on 42, which is probably like 40 or yeah. So all of this render graph stuff is gone now. The scheduling here will have to change a little bit. So it's really just this section here that's going to change. This is going to be something like add systems, core 3D. We have some system that is yet to be determined. We probably have an impl later on this file, right? Impl view node. So here's our custom draw node and our custom label. These are both going to go away. They're not going to exist anymore. The draw node here is, we're trying a section texture. So let's call this like draw section texture. Section texture, for those that are unaware, is my name in this example for the IDs rendered to a texture for each mesh, effectively. So in this demo, what it's actually doing at the end of the day is there's a bunch of like effectively vertex attributes or vertex colors. And that allows you to sit inside of Blender or something like that and define the data for the vertices. And when you do that, it determines where outlines should go. So you can get outlines like in the middle of a cube or on the outside of a cube or like, you know, based on the differences in that section texture. So it uses the red channel and basically just detects a difference. And if there's a difference, then it handles it. So our query here is going to be something like view query, and then the same stuff we had. View query is not in scope right now, so we'll bring that in. Unwrap, type to type argument, remove unused parameter. Did I get this wrong? Let me check this is the custom render phase. Let me check the view query on main. View query tuple. Weird that that's an error. Can't find core 3D. Yeah, can't find type. I don't know why Rust Analyzer isn't giving me like the ability to import this. It just feels weird. But we'll continue a little bit because basically that's what I'm going to have to do. I'm going to have to import that and then it will fix. Where's core 3D? Core 3D is here. Oh, you know why? Because this actually is not syntactically correct. So we'll get rid of this view node. We'll get rid of that view query. This view query is going to come in for us. This run function, we kill the front part of. And then we're going to kill this like ending brace here to bring it into this function. This is not syntactically valid. So we'll get rid of the OK and a curly brace at the end. Now it is syntactically valid. We need render context, section texture, which we're querying here for the view query. Graph view entity changes. Section phases, I think we have in our view query. Render context, same kind of thing. Command buffer generation task. Why am I using that? Guess that's okay. So one of the things that we need to do here is basically, this behaves a little bit like single, if you're familiar with single. So view into inner. Would help if I could type. So this is going to be this equals this. This is going to be destructured. What do we call these? Extracted camera. Do we use extracted camera? We have to, right? Camera. I'm going to call this camera. I'm going to call this probably just target. Forget what this is called. Section texture. Depth is probably what I call this. Render context is something that we need to get from a resource. So this is going to be render context. Technically, actually, I don't think it's a resource. I think it's a system param. Wait, do you mean the render graph is gone? It is gone. Gone. It's all schedules now. Don't know why there's an issue on S. We'll deal with that later. Section phases needs to come from here, which comes from world, which is a resource. So this resource, we're going to pull up into our query. So there's going to be section phases. And this is going to be res wrapping this. Technically speaking, I'm going to leave it to do here to check to check to see if this should be an option for this resource. I don't know off the top of my head, but we will find out. If this runs and crashes, then we do need an option. If it doesn't run and crash, then we are good. This is going to change section phase. Can't return OK here because we don't have that result. So we're just going to return. I could put a result on this now that it's a system, but I don't really feel like it. Because I don't plan on crashing the application is really the thought there. Bevy does have like a result type here that we could use. But if you return an error, you have to reconfigure the global error handler. And I don't do that in every single example. So I basically just don't use the result here. Because I basically, if I'm going to crash, I want it to panic. So I'm just going to write expect instead of returning. And the default in development for the global error handler is to crash anyway. So I just end up not using result. Even though you can change the global error handler to warn. That's crazy, but intriguing. Is this a 0.18 change or a coming one? This is a 0.19 change. This is in the 0.19 dev cycle. So it's very exciting, but it is not going to be out for another 2.5 months. View entity, I think this just comes from the view at this point. Let me check. View entity is view.entity. Yep. Why is depth an issue? Depth is here, view depth. That feels weird. And check that error. We actually do need world because we're using render as well. So we'll just do world up here. Don't need mutable access, so we're good. This doesn't become an exclusive system or anything. And then generally we're good. So we've got a couple of errors left. We're in lib, edge detection, render graph and graph. I guess my old, when I asked Rust Analyzer to pull these things in, it re-added. Let's comment these out. So this won't necessarily run at the moment. Graph Core 3D, sure. I think I had some old imports here. Am I not in the same file? Hang on. Sorry. I may have really just I'm not in the right folder. Okay. I have a lot of Bevy examples folders on my computer. Because I make a bunch of different changes like this. So I have a 0.19 version of the folder. I have 0.18 version of the folder. I have more folders for Bevy examples for new examples that I'm trying to add. And sometimes I forget to deal with that. So we're just going to make a couple of those changes again because I messed up. It's going to be like add systems, core 3D, and then like something here. This core 3D needs to bring in. You were actually trying to learn the render graph right before 0.18 come out, and it was a struggle. What were you struggling with? That's always like good video content for me, so I'm very curious. I was thinking about with the render system stuff, since everybody's going to have to learn it from scratch, actually doing some like workshop content on render graph stuff. But it's tough to get into the render graph stuff without starting at the high level APIs. Like there are people that don't know what a fragment shader is, right? So it can be tough to start at render graph. So we're going to get rid of the label, get rid of the custom node. We're not going to use those anymore. We called this draw section texture, if I remember correctly. I'm gonna have to go back to the other file and like revert those changes. View is going to be view query. We're just going to pull this tuple in. Now this should, yeah, okay. Now we get the actual import because the import exists because we are now using the appropriate version of Bevy. That was a really silly mistake. Section phases. This gets the to-do that we had. How did I end up with that capitalization on to-do? That was so weird. One of your biggest confusions was the difference between nodes and subgraph nodes and when to use which. Like when to, I guess everything is a node. But yeah. Typically the suggestion for what to do with the render graph prior to 0.19 especially is if you can do everything in one node, you probably should. The overhead of using multiple nodes to do whatever you were trying to do is high enough to be like a moment of pause. If you were going to like do a whole bunch of different rendering stuff, maybe you would want to split it up into different nodes, or split it up into different, draw commands and stuff. Like in this file, there's some draw commands somewhere. So like draw mesh and etc. Right? So set item pipeline, for example. This is a type. These things get executed when we're going to do our render phase and whatever. But it's like basically a series of incremental buildups of that render pipeline. So if we start with set item pipeline has an implementation that will literally just set the render pipeline. Like it takes your render pass, sets the pipeline to the pipeline for the item. If we go to mesh bind group, same thing. It has a view query. And this just does like one thing, right? It just sets the bind group for the mesh data and moves on. Same thing for these, right? I have one here for my own stuff, set section texture bind group, which just sets the bind group for that data with the relevant like data. So in general, if you were trying to do something previously, unless you really needed to separate things out for organization purposes, or if you had an overriding other reason to do it, my suggestion would have been just write one node, put it in the graph where you need it to be, do everything in that node. You can do whatever you need to in that node. You can go as low as you need to in that node. You can run multiple, we'll call them commands, I guess, in that node, etc. Same for Xavier. The struggle is more how it all fits together. Pipeline, render graph, render pass, render phase. Yeah, I was thinking about making a video on this and I was like, so you might have heard about the render. To get an idea of what you need to do. Yeah. So there's a lot of things that are like the render thing, the render this, the render that, the render whatever. And there's a lot of vocabulary there for sure. There were so many built-in nodes you couldn't have your head around when to use pre-pass or post-processing or where to slot them in for what you wanted to do. Yeah, there wasn't really a good visualization. Now that things are systems, we get to take advantage of like Bevy mod debug dump and stuff. So you should be able to dump out the order in which things are happening. But I've also found that, so secret website for people who are working off main only. Don't use this if you're working on the stable version. But if we look at Core 3D systems, it's now significantly simpler. And these are sets. So if you want to do something in the pre-pass, you do it here. If you want to do something in main pass here, if you want to post-process something, you do it here. And I think that is just like a much simpler way to think about it, which is nice. Obviously, their like schedules can be nested and stuff. So this isn't quite how simple it actually is, right? If we do for 3D systems main pass, we should be able to find a number of things. This is the migration guide. So here's PBR doing a late shadow pass before the main pass. This is MSAA right back before main pass. Occlusion culling before the main pass, before post-process. Or after main pass, before post-process. Sorry. Wireframe after main, before post. Copy the depth texture after pre-pass because that's when it's generated, and before the main pass. So like you can see how these things get a little bit simpler to think about. you don't quite get like when does the depth run in comparison to a different pre-pass, main pass, like in between thing. Well, that's the same thing that you get for normal systems. So once you did not figure out which existing nodes in the graph you should connect to or not, and disconnect or inject your node between the existing connections. Yeah. It was definitely hard to figure out which nodes were there and which ones you should connect to. Basically, if they weren't mentioned in an example, it was kind of hard to figure out. That said, node is a trait, and here's a bunch of nodes. So if you were going to order relative to something like camera driver node is a really common one, etc. But I do agree. I think that this is more simpler to understand. You have to learn scheduling anyway. Render graph was like a completely different thing. I like this better. Yeah, Bevy mod debug dump works or will work for 0.19 visualization of those systems. How will more complex rendering and shader material stuff work in the scene format? Not entirely sure what you're asking there. Like, is there a specific case you had in mind, hypercodec? Because typically, if you're just gonna like spawn, I don't know, some random scene, we'll say like a GLTF scene or maybe another kind of scene, like a standard material will get placed on an entity, and it would be the same as today, right? So like I could kick into like a whole overview of Bevy's rendering, but that seems maybe a little overkill. So yeah, not entirely sure what specifically you mean by that. There are high level APIs though, is the way that I'll frame it. So if you look for standard material, this implements the material trait. It's a little bit more complicated than an average, like a custom material. But this implements the material trait. This is a component, or not this isn't a component anymore. Sorry. This is an asset that you have a handle to that you stick in the mesh material 3D component these days. And this signifies that it's supposed to be effectively like a render pipeline that applies to that mesh. Well, if you just want to spawn a camera with post-processing or a material with a specific frag shader that controls its rendering. For a material with a fragment shader, that's what I was just talking about. So there's a material trait, like the same thing, the same way it works today. Are you familiar with the way it works today, or are you kind of like new to Bevy? Basically, this is the TLDR. You have a struct. It derives a couple of things to define how that data gets translated into like a buffer that you can pass to the GPU, a uniform buffer. You can specify samplers and textures here as well, alongside some other things like storage buffers and whatnot. You specify which shader is going to accept that data, and then you have to write both, or you don't have to write the Rust side of things, but you have to write the shader side of things to accept that data. But this just like anything that implements material can go in like a mesh material 3D or 2D. So this is a component. You have some struct that is effectively an asset that you have a handle to, and you just put that handle in the component. You get the material shader part. You weren't sure how you're able to specify that in the scene format itself. It's a component, so I guess I'm not sure what scene format you're referring to, because all of the scene formats I'm aware of allow you to specify components. Even if you look at the like, where is SCN? Let's go assets. Even if you look at like the old scene format that is like pre-BSN, not GLTF, and it's just like a RON file, Like all of these components just live here. Handles are a little bit weird, but I guess like what is your actual question? Like, are you asking how BSN is going to treat it? Um, are you asking about how that's specified in GLTF or handled in GLTF? Are you like, do you have a custom seam format that you're working with, etc.? Feel free to not answer. The as bind group you could not derive and had to implement manually because you needed to pass a texture from a resource to a material shader. So in my impl, you could access the textures not using derive. Is that the correct way? To finish up the other question, BSN and handles were the main thing. I am not going to, I think, I don't think I'm going to talk about how BSN is going to treat things. I will point you to the PR that is currently open. There is a channel in the Bevy Discord for this specific purpose. And there's a bunch of stuff here that talks about how patches are applied and things like that for handles and other things. I will say that as far as I'm aware, the only thing currently implemented is the BSN macro and not the BSN asset format. So I actually don't have an answer to your specific question because I don't think we know what the asset format is actually going to look like. There have been some prototypes in the past, but the current version of it, as far as I'm aware, does not currently have an asset format. It will at some point, but the current effort is really centered around the BSN macro more than it is the asset on disk. So I think we don't know. As a community right now, we generally speaking don't know. And to say it would work one way or another on stream is not something that I really want to do. Okay, so the bind group question was, you couldn't derive and had to implement manually because you needed to pass a texture from a resource to a material shader. Is that the correct way? You need to pass a resource to the material shader. I would make that resource an asset. Is it just, yeah, it's just a texture, right? So you should have like a handle to an image or something. If you make that a handle to an image, you can put that in as bind group without the derive. Another possibility would be to always bind the texture your material needs to all shaders, not just your material shader. I don't think you need to do that. If you have a custom material, you should be able to implement as bind group and you should be able to pass a handle in. Yeah, so if you just have handles, then just pass the handles in. Unless you're trying to do something custom. If you're trying to do something custom, the answer gets a little bit more complicated, right? You get to choose things. But if you look at the standard material, it accepts handles, right? Like base color texture, option handle image, for example. And this is an as bind group implementation, if I remember correctly. Maybe it's not these days. Yes, it is. As bind group. So I assume you're implementing material on some level, and you need texture and sampler, and this can be an option handle image. So if you're comfortable just binding those three handles to your shaders, then do that, because that is the simplest path. You don't need to kind of like escape out and try to pass them in manually, because handles are not copying the actual data. It's just incrementing a counter, right? Effectively, like these are arced references to an asset. So if you clone that handle and place it on all the materials that use it, then that's fine, actually. If you wanted to do something a little bit lower level, you could, right? But at some point, you would need to use one of the lower level APIs for that. Also used a single sampler constructed by hand for all the textures, not 3 samplers, not the samplers made by the asset loader. Yeah, that's fine. Well, so the thing that I'll say is Bevy's image is actually a texture, right? So Bevy's image contains not just the image data, but also the sampler. Right? Data is a vec8, and then the sampler also exists here. We were just dealing with this for Skeen's handle image support, actually. So if you have 3 images, then what you have is 3 vec8s and 3 samplers. And the simplest path forward is to just take this texture and pass it in as a handle for 3 handles and just do that in your shader as well. That also gives you more flexibility. If you don't want to do that and you wanted to try to use reuse stuff or whatever, then you have to use lower level APIs. Is there a way to experiment with the coming render changes? Clone the repo. That's it. That's your, I mean, you don't have to clone the repo per se. What I do in the repo that we are actually working in right now is you can specify dependencies like this. Note that if you do this and you use anything that isn't just Bevy, you will actually have to specify them all, which is why I have a list of like 50 crates here. Just to make sure that all my transitive dependencies are covered. I'm not necessarily using all of them. But this is like, you can just grab main off of Git. I would probably suggest if you're going to do that, to use a rev and use the commit hash as well to do the dependency, just to like know which one you pinned to. I personally am very comfortable in this sense, so I am intending to like update this every time I look at it, which is why I'm not doing that. But I would suggest that, yeah, it merged. I generally don't talk about things that haven't merged. I'm aware of a lot of stuff that is happening, and I don't bring up things that haven't merged. I think that there's a lot of weight that you can put on things accidentally if you start talking about work that people are doing but haven't merged and still need to get done. Because then people start to expect that it's going to land. That adds pressure to the contributor. That adds pressure to the person working on it. It adds stress to the process. And you have to remember at the end of the day that basically everybody that's working on Bevy is a volunteer. So if somebody's working on something really cool and they're being very loud about it, like the weasel stuff, I feel comfortable talking about because some of the people working on it have been around the Bevy ecosystem for a very long time, and they are pretty committed to doing the weasel stuff. I feel pretty comfortable saying that the weasel stuff is like a goal that people want to achieve, and that there are people currently working on things that are headed in that direction. I can talk about WGSL Analyzer and stuff, or the spec work, but things that are just like sitting in a PR, I try not to talk about until they merge. That's kind of my bar for things like This Week in Bevy and stuff. You were thinking that just binding with a single nearest sampler would minimize the GPU resource usage compared to using 3 shaders. 3 shaders? That's not 3 shaders. 3 samplers, you mean? I don't think that 3 samplers is overhead. Is WGSL Analyzer getting work done? Yes. WGSL Analyzer is getting work done constantly. WGSL Analyzer is an active project, is the way that I would frame it. There are people actually doing things. This is the most recent thing that I'm aware of, which is that import support in WGSL Analyzer is being implemented. TLDR, the state of WGSL Analyzer right now is they have effectively dropped support for the Naga oil stuff, and they are implementing like true core WGSL and Weasel support. So things like imports are landing, as you can see here. This is just the first phase of imports, so it's important to note that like, yes, stuff is landing, but also it's not just ready to go, right? There's a to-do list here, so you can see that the parser, the syntax tree, and rejecting imports if you're in a WGSL file all work. That was all in that PR. But actually resolving those and doing a couple of other things is not implemented. So there's definitely work happening. Things are being merged. WGSL Analyzer is progressing. It's being based on Rust Analyzer. So yeah, I'm really hoping that we can get Weasel into 0.19, but there's a couple of things that really need to happen. And I don't want to commit anybody to doing that stuff. People have lives, you know? So hopefully it gets into 0.19. If not, it will get in eventually. I'm super excited about it, so I'm trying to help out a little bit, but there's a lot of people that need to put specific kinds of work in. Yes, Long is right. WGSL Analyzer are getting work mostly towards Weasel support improvements. I think it works fine for WGSL currently. It just doesn't work for the Naga oil extensions, which is expected. But yeah, Xavier, I would not optimize ahead of time. I would pass the 3 handles in. You'll get the 3 samplers. You'll do things the way that everybody expects them to exist inside of Bevy. And if you benchmark later and you have an issue with a low poly, I have a real hard time thinking that you are going to have a problem with 3 samplers. But if you end up having one, then you can always deal with that later. I would say do the easy thing. Optimize after you benchmark. With render graph is gone, the title, do you mean the render graph has systems? I do. I do. That's what we were working on over here. We have a couple more things to do over here, actually. Get rid of some of the syntax down here. Camera, world. We need world. World, shared reference to world. Waddle. None of my typing is going in the right order. Let's see. Render context. Render context. I really like the changes for render systems and the removal of the render world. I'm definitely vibing with it. Camera, target, underscore, section texture, depth. View dot into inner, because the view query is kind of like single in that way. So we're just destructuring at the top here. This is going to be view.view entity. This is just not going to be an OK. Render path descriptor needs a multi-view mask. Multi-view mask is not something that most people need to care about, generally speaking. The two things that I can think of that multi-view mask are for are VR and some really advanced rendering stuff. Wait. Removal of the render world doesn't no extract anymore. Did I say render world? I mean render systems. If I said render world, I misspoke. Render systems is implemented. Render graph as a structure is gone. Render world still exists. Extract is still a thing. This is not getting scheduled, so I'm still anticipating some issues here. Yada yada. Let's get rid of query item, core 3D. And this is draw section texture. Let's inset core 3D systems. Is this going to work if I put it in the pre-pass? I don't actually even know. Where did I have this before? I had this in main pass before. I think I'm going to stick it in main pass. So we get rid of the render graph here. We use systems. This is significantly nicer. Core 3D graph. Oh, this is going to be in post-process, isn't it? Yeah, post-process there. Perfect. So I think we're good on lib.rs. We got to move over to post-process and make a couple of the same changes. This example is two things. One is a custom render phase that renders the section texture from all the meshes that exist. And then another is a post-process that uses that section textures and the main pass texture to draw outlines. Okay, yeah, you were going to say, render graph with the render world. Good to know it was a misspeak and you didn't miss something that big. Yes. There are some people who want to remove the render world. I don't think there's any plans, like concrete plans for even how to do that in the first place. At least I haven't seen any. So I'm not expecting that to land for a while. We still have passes though. You mean like render passes? Do you not like render passes? It's like I'm like I feel like I can't even think about how you would get rid of render passes. Like you just don't want pre-passes to exist, or what's the thought there? I'm curious. In the meantime, I'm going to make a couple of the same changes we just made to that file, get some render graph stuff out of here. This is going to have to run in a specific place. I think that what I'm going to do here is go take a look at the current example. So even though I could probably like shuffle my way through and pick something that would probably work, I think that because I know there's a custom post-processing example and I know that this code exists on main, looking at this is probably more useful than guessing. So that puts that here. Do I have that init? That init probably exists for me. I probably missed that in my other, well, maybe I didn't, but we'll see. So post-process label isn't going to exist anymore. This currently exists between tone mapping and the end main post-process. And then this just runs in post-process, which is interesting. I feel like coordinating. When does tone mapping run? Let's go find out when tone mapping runs. Let's look for tone mapping in two places. I'm going to look at the dev docs. This is just a component, but we really need to know about the pipeline. Tone mapping, init tone mapping, and render startup. So render startup was a previous change that happened fairly recently. It's very similar to the startup in the main world. It's just when the render world starts up, same thing. So that's where people are starting to put like this pipeline initialization. Render, prepare, view tone mapping pipelines in render systems prepare. Would this be in camera on the HDR pipeline? So trying to think of what exactly I should be searching for here. The thought in my head is basically HDR is a component that is probably per view. There's like a draw camera is the wrong thing to call this. It's not set item pipeline. We have this somewhere. I was looking at it earlier. Draw functions, draw section. For set item pipeline. Here we go. Vulkan at least prefers dynamic rendering over the past system nowadays. It's probably unreasonable to remove them since you assume WGPU and every API besides Vulkan still uses them. Yeah, there's a lot of like cool Vulkan stuff that I feel like we probably aren't going to do. Xavier is saying tone mapping should be done by calling an imported function in the material fragment shader main post-pass lighting processing. Only if you don't have an HDR node, right? Tone mapping, to my understanding, if you don't use an HDR camera, has to exist in inside of like the material or whatnot. So like inside of Sprite, for example. But if you have an HDR pipeline, it happens at the end for the camera. So there are multiple places that this happens. Having a bit of a brain fart here though. SView bind group, system pipeline. I swear I had this up in a window already, which is why I'm looking for it. That would make sense in an HDR pipeline, but you know this much more than you. You're just kind of like, yeah. So the demo that we're working with is HDR, is something that I'll mention. I used HDR because I wanted more resolution in that particular render texture, and I wanted the F16 support instead of the what is it, like U8 or something. TLDR and dynamic rendering from Lond. Desktop GPUs basically don't utilize the information provided by render passes, so they're basically just pointless boilerplate. But mobile GPUs, especially old ones, use it. Yeah, that makes sense. I think there's a lot of really cool Vulkan stuff. At some point, so I got some suggestions from Griffin on how to approach doing like Vulkan triangle and stuff. So we may at some point do a series on um, there's some cool Vulkan like how to do a triangle stuff out there. And I think that getting into some of the extensions for Vulkan and just talking about them could be really cool in terms of rendering content. Uh, it isn't necessarily going to directly apply to Bevy, but it's interesting stuff nonetheless. What's the HDR status with Bevy nowadays? You think the renderer can do it, but in the end, it's still tone mapped to sRGB primitives? HDR internal SDR output is my understanding. I don't think that Bevy produces an HDR output. Like at the end of the last thing, right? I think if you have an HDR monitor, Bevy isn't producing an HDR signal to that monitor effectively. But internally, it does a bunch of HDR, and then it does the tone mapping at the end of the process. Yeah, unfortunately, the Rust ecosystem is lacking with windowing HDR output. Yeah, HDR would be very cool. I say it would be cool, but like cool in theory is kind of like where my brain is at. I don't necessarily feel like I need it right now. But definitely in general is just like cool to have, right? Yeah, when it could use a couple of improvements. But when it is a huge, massive, complicated project, so that is just how that is. Okay, here's the tone mapping function, right? So you can see already that here's a view query, right? We're looking at basically the same thing that we're writing in this other file. Let view uniform offset, target, tone mapping, etc. And then this gets applied somewhere in here. So really we're looking at or trying to look at where this is being scheduled. And it doesn't look like it's actually being scheduled in this file, which is kind of unfortunate. So let's look for tone mapping. Try to cut down to core pipeline just so that we get something. What were we in? We were in tone mapping node. Maybe it's in tone mapping mod. Plugin for tone mapping. Add systems render, prepare view, init view. So this doesn't run, or this doesn't schedule the tone mapping. Interesting. Wish we called this something other than tone mapping as a system name. Because if I search for tone mapping, it's just going to pop up everything. When it is finish, like, yes, it's complicated, but it also been less than 10 jumps till I arrived at platform API calls so far. I mean, like, I don't think when it is complicated in the, like, it's impossibly complicated and you could never understand it kind of thing. I think it's just like anything that tries to do wide multi-platform support has to deal with multi-platform support. And multi-platform support is annoying. Just right, like if you could just ship to Switch or just ship to a PlayStation 5 or just ship to, you know, a specific computer with a 5070 Ti, things get so much easier. Tone mapping, tone mapping, tone mapping. Here's tone mapping. That's WGSL. Core 3D, tone mapping. Here we go. So it's just in post process. I think That's an interesting question. It's an interesting question in my mind because I was running this after tone mapping before, right? That's why we got into this in the first place. This example schedules itself, post process. This example schedules itself after tone mapping and before the end of the main post process. And I don't think that's what we want for an outline. I think we would want an outline to run somewhere else, right? We would want this to run probably per view. Hmm. I think this is the first example of something where I would want to know ahead of time where these systems were, which is the same problem we have with the render graph, where it's like, okay, there's a bunch of labels and stuff. But where do they all run? All right, so Core 3D is prepass, 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 chain. That's all prepass. Then main opaque, main transparent. This is not in order. So these are scheduled in Core 3D. These are scheduled in prepass. These are scheduled in main pass. These are scheduled in post process. Where is the system set up for Core 3D? Core 3D base schedule. Where is Core 3D base schedule? Let's do Core 3D base schedule. This returns a schedule that configures the sets for pre-pass, main pass, post-process chain, which is kind of what I expected, but I was hoping there was going to be something more. Just shipping on your computer with your compiler and compiler options much easier. UB is always what I need. You think Bevy can dump the render graph, right? It already did. That's what I'm talking about right now. I think I saw, yeah. Replace render graph with systems 22.144. Merged this week. So the render graph is gone. Gone. Like it got deleted. And now it's all systems. So this is the new, like, how things are set up. I think that because I had this example running after tone mapping, I am going to run this after tone mapping. But I think that while this can be a post process that runs after tone mapping, it probably shouldn't. So I think that there's a change or a fix to be made here. But in the meantime, we will run it between tone mapping and end main post processing. So post process system is going to be our post process node here. We are going to need to get rid of our label in our node and call our function here. One of the nice things about having all of these examples is it gives me practice for upgrading some of the libraries and stuff that exist. So I do maintenance on other stuff, and then that is this is like good and useful work to get some, I wouldn't say practice necessarily, but get some context before I actually go and, like update Bevy ECS tile map or something. Which I think I'm going to try to keep Bevy ECS tile map and stuff up to date with main this cycle, considering the changes that are going in. I think I missed a comment. Let me scroll up. Yeah, right. There was a lot of overlap in regards to system scheduling and building a render graph, but you wonder if this is the right decision. Well, a bunch of people talked about it on the PR. So if you are interested in that discussion, one of the nice things about open source is that there is a ton of review on this PR. There's everybody's concerns, everything that could have been done differently, etc. Cart reviewed it. Ice Sentry, Charlotte reviewed it. Francois did some review, although I don't think he did rendering review. Vero reviewed it. So there's discussion here. If you wonder if it was the right decision, that's where I would point you. I would say, go look at this PR, read through everything that people were saying, and then ingest that information to figure out if it was the right decision or not. It is the way that it's going. So this merged. Unless you found something that was super egregiously broken that nobody else saw. This is the way that things are moving forward. But, not ruling out that is a possibility theoretically. Is it possible everybody missed something? Sure. I think that PR got plenty of review personally, though. Pipeline cache. Part of the reason that this is happening is because scheduling is getting better and better and better. And taking advantage of that, there's a huge benefit to, and I've said this to many of my clients in the past, there's a huge benefit to sort of riding on the coattails of a system that is already working, if that makes sense. Do you use WGPU or do you implement your own Vulkan renderer? Why did I close that file? For example, as an architectural decision, say you're going to build Figma, right? Do you use WGPU or do you build your own Vulkan renderer? Things like which platforms are you going to support? Things like how many people do you have on your team? How many of them are rendering experts? If they are rendering experts, how many of them have shipped products before and can do deep rendering work, but also in the context of say a startup's timeline, which is a different environment than doing rendering deep research, right? All of those things have to go in. And then you have to consider the fact that if you are going to write your own stuff, you have to handle everything. You get zero support for that. You have to come up with all of the new innovative technology and things like that. So if I was a small team, right? If I was just me and I was going to do this, for example, and I was going to build Figma, I would consider building Figma on top of Bevy, right? Rather than building on WGPU from scratch even. Because of things like this. Yes, this is a change, but yes, a lot of people have thought about and discussed this change and decided that this is a better path forward. And as a person doing some other work on top of it, you didn't have to think about any of it. This just happened for you. And And it's really difficult to underestimate the impact of being able to be on the train that is already moving versus needing to, dig up the coal for your steam engine yourself. Like those are two very different things. It depends on your goals, obviously, always, but there's a really, really, really big benefit to hitching yourself to a train that is already moving. Lon says, right IRC, if you remember correctly, we recently got runtime system removal too. Yes, we did, which has potentially neat implications for this render graph stuff. Does it? What is one of the implications? I'm trying to like, technically speaking, yes, you could get rid of them, but that causes a schedule rebuild. So when would removing it be better than checking like a Boolean, like a run condition or something? I think I have that same question for main world stuff. Right? Like when would actually removing that system be better than a run condition? And I think that the answers that come up into my head are like modding and scripting use cases where you can load a mod in, it adds some systems, and then delete it. And get rid of those systems that we're running. That feels like a reasonable like insert remove process, but that is not like a regular everyday use case at the moment. You feel like you'll see custom system param implementations for render graph systems to combine commonly needed resources and queries relatively soon. We already are. Render context is a system param, right? Which combines a bunch of state with the render device and the diagnostics recorder. This is literally has already happened. Don't disagree that there could be more. There might be more happening on that front, but this absolutely has already happened. Loading into a different level where you're doing something completely different post-process. I don't know that I agree with that. I don't know that I agree with that because the way that you can switch post-processing is by switching the relevant component on the camera. Right? Like you don't need to remove all the post-process systems because them existing doesn't really matter. You can just swap the component on the camera from overground to underwater, right? And then it will run a completely different post-process for you because you should be filtering for that component to run the post-process. So I don't think that you need to remove systems to be able to achieve that in a performant way. You get a feeling it would make A/B testing stuff really easy. Plus, it's needed for hot patching in new systems and lists with this work, which means it'll also work with render graph. It's needed for hot patching in new systems and lists. And with this work, that means it'll also work with render graph stuff. Oh, yeah. Hot patching, I see that. I would like to see more improvements in hot patching. I haven't made hot patching one of my like daily driving use cases. Yeah, parameterless. It took me a second and I had 2 reads, but I got it. The hot patching hasn't made it into my daily driving yet. And it hasn't made it into my daily driving specifically because pretty much every project that I work on has more than just a main binary, more than just the main entry point. Hot patching is very, very, very cool. I am excited to see where it goes over the next couple of years. But it currently has drawbacks that make it kind of like I would rather not have any issues than have hot patching personally. I know that other people swing the other way. They're different, sort of risk profiles, if you will, for that kind of thing. Um, but for me, I work on so many different things, and hot patching is something that it feels like you have to have already built to get the benefit of. And I do a lot of from scratch building. What do I mean by more than just a main binary? I mean main and lib even, right? Two crates. Not just workspaces, but main and lib, I believe also does not work unless something has changed. So like you can have one package with two crates, and that's an issue. I would be very happy to be corrected, but last I looked into it, that was still the state of it. What else do we have here? We have so separate .so or just separate crates also breaks. If you have a main.rs that pulls in a lib.rs, that doesn't work from my understanding for hot reloading. Similarly, what Lond is saying, where if you have a workspace of a bunch of crates, like a bunch of plugins and stuff, the hot reloading won't work in those plugins. I think that there's an open issue on the sub-second repo. No, maybe it's not I think it's the sub-second repo about it, but I haven't seen really any progress on it. So I think people are aware. Somebody just needs to like actually do the work, which is, the state of open source in general. Inset. Did I not name this? I did name this post-process system. So what is the problem here? Still a couple of changes that need to be made. Why is Rust Analyzer's not happy? Restart Rust Analyzer. Oh, we'll have to check why these other limitations seem strange. I think it just hasn't been implemented yet. I don't know that it's like I don't think it's like a hard technical block in the sense that it's impossible. I think it just is more work and nobody hasn't done it yet. It's a Rusty issue, not something Subsecond can easily fix. Oh, really? So the work is potentially deep then to fix that issue. You would have to go work on Rusty then, which is a very different thing than. Maybe I should just change this post-process to be a full screen material. I guess we can't pass in images yet, so maybe next cycle. Post-process 63. So what is wrong here? Tone mapping needs to get brought in. What? Did this not save? Cargo tree Bevy. One version. .019 dev. Sorry, let me make this a little smaller so that I can read some of these, because this says to me that things are problematic for core pipeline. I really don't like that. — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — — This is just an API change. It's going to be fine. View entity needs to change. That's fine. I think that's fine. I think all this is actually fine. These are just small API changes. Smaller text is better for you. Okay, I can reduce it a little bit. I think that these errors in particular are very long and wide, but I do try to make things bigger because I know people watch on phones and TVs. So I usually work a little bit bigger than is like really comfortable for me. But erroring on the side of a little bit bigger is usually better. Out of curiosity, is there an easy way to use debugging tools and breakpoints in Bevy? You tried in VS Code and it doesn't want to work. I don't use them, so I can't really talk about it. I don't feel like I've needed them either. I do like replay debugging for GPU stuff for shaders, but I don't feel like I ever really need it for Rust. Thanks, Clutch. I appreciate that. Glad you're enjoying the videos. Although the architecture of Bevy makes it kind of hard, useless if what you debug is not constrained to one system. Debugging is much less used in Rust. Yeah. Let me fix some of these other things, and then we'll come back and try to figure out what this inset issue is. Mesh uniform. Inverse transpose became an affine extension. Interesting. Nope, that's not right. I wonder, so this looks like code that would probably be in the example. Post-process system, bind group, maybe not. Oh no, this is lib. This is custom render phase. This isn't post-process. Sorry. I was thinking of a different example. So on main, this is inverse transpose 3x3 and 2 transpose. So this looks correct. So we're just going to import that extension. I don't know why that isn't in Prelude anymore. Maybe I deleted the import earlier and didn't realize it. But good example of why it's useful to go check what is actually being used in other places. Retained view entity is no longer interesting. This is one that I'm unaware of currently. Extracted view, retained view entity. It's right there. Extracted view. Extracted view. Just the wrong variable. And then add command buffer generation task. Good to know, thanks. It's just hard for you to track state changes with functions with a lot of side effects. That's why you write functions that don't have a lot of side effects. You know? That's really the approach, honestly. You wish system stepping was easier to set up. That plus inspector could be so nice for debugging. Yeah, system stepping being easier to set up would be really cool. I agree with Lond as well. If you could give an example of like function and side effects and stuff, people could probably give you either ways to rewrite that or suggested debugging techniques. Did nothing change this recently? Weird. This was in March. Does this API not exist anymore? This feels like a WGPU thing. Yes. This used to be on render context, which is a Bevy thing. Let's take a look at render context. I'm assuming this is, let me, render context. This is probably render systems related. Let's see. So we had command buffer before, which appends a command buffer, of course. Maybe we just don't do this anymore. Maybe we're supposed to create the command buffer ourselves. Inserting, removing, mutating components, resources is a side effect, and print line is similar. Also, no side effects, purely functional looks difficult in this case to me. What do you mean by in this case? I didn't see a case roll by in chat. Or in the case of inserting, removing, mutating components and resources, you mean? I think if you're debugging stuff like that, you should enable track location. Wherever this is, track location. Track location is a feature that will tell you where things got modified from. So you don't have to guess. If something changes, you can log out how it changed. And of course, if you take a purely functional definition of side effects, you end up with no mutable anything, and like, there's tons of that. Yeah. But commands are just a queue of function pointers, simplified. Yep. For example, and you don't think asking for commands to be DI'd and mutating it, calling that side effect makes the term meaningless. Yeah. Yeah, I think that when most people think of side effects, they're thinking of like managing a lot of different state. Like the way that I think most people think about side effects is basically if you have a variable and a for loop, and the for loop sometimes updates that variable outside of the loop and sometimes doesn't, like that kind of thing. Like doing any kind of stateful processing where you hold variables over here and over here and over here, and the code that like mutates them is like here, here, and here. Like those are the things that I think people generally refer to it like that. And in many, many, many cases, you can write code that doesn't do that. So instead of like thinking about it as instead of like, hey, you should go write Haskell, right? Um, Taking a little bit more of a practical consideration, because really when people talk about side effects, unless they have a purely functional programming background, they they don't mean purely functional side effects, colloquially. You suspect if your Bevy code feels very side effecty, it's possible your systems are perhaps too large. Yeah, I think I would agree with that generally. I think if you feel like you're maintaining state in a bunch of different places inside of one system and are having a hard time tracking that state, um, then there's something that you should be reformulating in general. I wonder if this removal was intentional. Um, September, October, March. It's tough to look for something that is no longer there on GitHub. And we can't search for non-main branch, right? I don't want tips. I just want like God, I feel like GitHub gets less and less useful every time I use it. Like, where's the advanced search button? I have to click one of these. So like, why would I need to specify repo here? I don't feel like searching every repo on GitHub is like such a common use case that the advanced search should be, let me search every repo on GitHub and not let me search inside of this repo for specific things. That feels like such a weird, like, anyway, inversion of the use case. Yeah, I could get log and whatnot. I want to do it on GitHub because clicking through things typically is better for stream, um, but yes, I could do local clones. I have local clones. I could rip grep through them. I could rip grep the log history, etc. The source here also is on the Bevy render context. I think that this is literally a Bevy file. So really what I'm going to do is I think I know that it was the render systems PR. I'm going to go check out the render systems PR and see if that. But you know what the problem is here? GitHub is fundamentally broken and won't actually let me look for anything but a single file on this PR. And Command F has been broken for years at this point. Where's context? Yeah, so render graph context got moved to render context. And when it got moved, I think that got deleted. It's not in here either, though, which is interesting. I wonder if this just got. I wonder if this was intentional. Where was the render context before? This was in renderer mod. So this is render context mod. Yes, I love mod.rs. Renderer. Oh, come on. Renderer mod. Render context. No note here. No comment. I think it was this PR that removed it. This is like, technically speaking, like a simple function, right? Command buffer push queued command ready, queued command task, and just flushing beforehand. This is in lib. So the other thing that's worth noting is similar code over here. Begin tracked render pass. What am I doing over here? I am doing, I draw a section texture, does the view query, gets those textures, and then my code here is setting up command encoder with a render pass, tracked render pass diagnostics. Is this just tracked render pass? Do I not need this anymore? Is that just this? Let's see. Begin tracked render pass. Viewport, set camera viewport render. Create command encoder, begin render pass. We probably don't need this. This is a tracked render pass. Set camera viewport, and then we call render somewhere, right? Yeah. I think that's it. I think we don't need this anymore. I think we delete this whole block of code. Oh, you use the global search filtered down by language constantly to find how certain NixOS services can be used. Yeah, that is not a use case that I have because I am always searching for a specific GitHub repo. I get how it could be useful, but I don't think it's the default, or it should be the default. You notice on a PR that GitHub cache web page content actually showed the wrong diff. Yeah, I don't know. I don't really want to get into that conversation, actually, now that I think about it. We're just going to skip that. Suffice it to say that I am less than happy with the path. I have a pass here. It's custom section pass encoder section pass, I think is what I call this. Don't think I have depth. Color attachments. I do have depth. So we're going to attach depth. And then viewport and this. Why do I have a random bind group commented out here? That doesn't feel good. Let's leave the comment. And I'll to do, what is this comment? You know, sometimes it really do be like that. So this is render path, set camera viewport. We don't have the resolution override here, but we could. And then items empty. Is this handling whether this is empty or not? It's an interesting question. Let's do the resolution override. The resolution override is just going to be another thing up here. I can't remember off the top of my head what it's supposed to be. So we're just going to look at the system. Main pass resolution override. This is not, unfortunately, the main pass, though. I guess it is, technically speaking. Yeah, I think it is the main, and I'm comfortable with continuing like that. This is going to be extracted view dot entity, I think. No, this should be view dot entity, right? No, this is extracted view dot entity. Maybe it's not. Why am I flipping back and forth here? This is view entity. View entity is view entity. View query. I have view query, right? View query, view query, view into inner. Maybe I've used this because I did into inner, so I put it up here instead. Color attachments. This is old. And we need a color attachments here, right? This is the same thing. Sections, color attachments. Did I remove my bindings? Hang on. Let me. Man encoder, render pass, descriptor, descriptor. Let me back up a little bit. I think I got a little bit ahead of myself there. I am using color attachments here. Okay. Question is, where were we using section phase before? Section phase render. Oh, that makes sense. That's not the one that was not used, was it? Color attachments, texture sections. What's wrong with color attachments? Option render pass color attachment found. Oh. And this is expected option render pass color attachment found option 1. Okay. Let me reference this then. Here's what it is. And then render context needs to be mute. And then we're down to just one error for our post-process system. I don't think Command F is broken because they use virtual scroll specifically, Lond. You can have Command F work with virtual scroll. They just didn't implement it. I didn't finish writing a to-do comment right here. Oh, to-do, should this be option res? Target isn't something we use, so I'm going to underscore that, probably take it out later. And then this is in lib.rs. So lib.rs has a scheduling issue. Can inset only be called? I guess this is because this is typically before and aftered, right? So let me brush up on my usage of this function. That's how it always works for you. Yeah, what I'm saying is that you don't need to break that just because it's a virtual list. From like a functionality perspective, you don't need to break Command F just because it's a virtual list. Maybe it's an indirect error because the function has a param that makes it not a system. Well, we can try. Let's take a look. So worthy guess. This is world view section phases, res, render context. I don't think any of these are wrong. And if it was wrong, then we could verify that by doing inset and getting rid of it. And then this would have an error. And then we would see the error. Invalid system configuration. So that's looking more likely. So what's wrong with this? Shared access to world doesn't need anything special, right? View query is a system param, right? Because it's a query. Resource, render context, system param. This doesn't need to be a reference, right? Let me take a look over here. Or 3D plugin, view query, nope. So reference, reference in option, res, context. Reference, res, context. You know what? This is not a component. Or sorry, this is, it's not that this isn't. Yeah, it's not a thing we can query for. So this is going to be main or resolution override, right? Cool. Not my favorite error on that one, but debugging process was a good idea. And then this will be the same issue because I definitely did the same thing down here. No. Pipeline cache, render context. This component uniforms. This is custom render phase. Now we're in post process, or we're more similar to the post process is kind of what I should say. All right, res component uniforms post process settings is what they have. That's also what we have. Render context is mute. This is wrong, I think. Instead of making it an exclusive reference, it's just mute render context because that's a system param. No HDR in view. Okay, we're looking good. We're in main now. HDR moved. So in theory, we're done. We'll find out. How would you not break it? The content is literally not in the DOM, but it's in the front end. Like you have all that data. Right, like virtual list, if you are dynamically fetching data that doesn't exist, then sure. But this virtual list on GitHub is really a virtual list for rendering purposes, not data fetching purposes. That's cool. What do we think that is? What do we think that is? Weird. Those are like shadows that are statically applied almost, but only for triangles. I think those might all be individual triangles. That doesn't make sense for the pyramid though. The pyramid is just one triangle per side. Do we think the shadow settings are just terrible on this example? It's flashing a little bit too. So we've got some debugging to do actually on this. I've noticed flashing in at least one other example as well. Oh, that's really bonky. Hang on. So in this example, you can click to turn the outlines on and off. And if the outlines are off, then everything is fine. And if the outlines are on, the outlines are rendering in front of other meshes, unless they are selected. That feels to me like a pre-existing problem, I think. I don't think it actually existed before. But I think in the port, it probably brought this to the front. You would guess it's due to a classic system ordering issue. I'm trying to think about where this needs to get ordered then. Or what system ordering issue would cause this, maybe more accurately. Are those negative values is a question in my mind. Let's run this with features file watcher. Bevy file watcher. Let's take a look at the post processing, which should have some of the debug code in here. So if we get rid of this render and we render the diff here, this is all of the outlines, and the outlines look fine. I think that are we not passing in the depth here is an interesting question. And right, because I remember making a change to the depth when I removed the command generation task. So the depth stencil attachment is not here for the post process, which I don't think is necessary. Depth would be your thought too. I think one of the things that I think I'm more concerned about the black areas than I am about the depth. The depth feels like ordering and solvable. The blackened areas feel like there's some math that's wrong now. You think black might be related to depth too? Okay, let's take a look at what this looked like then. So the Bevy examples repo is where this example lives. In examples, let's go to edge detection custom face. Let's look at let's start with lib and look for depth. And depth in lib is on and greater equal for this makes sense because we're writing out that section texture. And I think that this is fine. This feels like it's still working over here because the section texture is rendering in the right order if things are in that texture. So for example, this donut is in front of the cube if it's included in that texture, which makes sense. So we have basically two textures happening here. We have all the color stuff from the main pass, and we have like a texture that is literally just red. So while I was showing the Sobel filter earlier, I think I do have a texture load. That feels weird. This is the texture we're generating, and the texture we're generating is flashing. So where are we scheduling this? Not post-process, lib. We aren't. Here we go, up here. Did I forget to put it in the main pass? Is it just running randomly otherwise? Yeah, at least a little bit. Okay, so yes, ordering for sure. Um, Still some issues here. The outline definitely runs over. This is going to be a sit down debug session for me, I think, is what this is going to turn into. This is something that I'm probably not going to have an immediate answer to on stream. System ordering related, maybe, but I haven't dug in deep enough to know which ones are at fault. And in theory, this could be related to how it was implemented. This flicker is more like Z fighting. Sure. The sampling renders fine. Right? So I think one of the things that I'm curious about here is the problems all exist on things that are not the outline. Right? The flickering on the regular meshes is not actually related to the texture. Render dock time, I'm not on Windows, so we would have to take it into Xcode. Render dock would be very useful here, though. I think this is a problem in the regular rendering, not specifically in the outline. Though render dock works on Linux, yeah. Maybe I'll stream off Linux at some point. One of the a question that I have is there's basically a very similar example in the Bevy repo. Sys git pull cargo run example stencil. Maybe custom render phase instead. So this will take a second. Seems almost like random draw order plus lack of depth buffer, but if the depth buffer was actually missing, the torus would be wronger. Yeah. The outline issue feels separate from the black textures on the meshes. Because when we only render the section texture, that red texture, it shows up and it's fine. So what that says to me is that the main pass texture is getting the weirdness, right? Like if we only do this, Return texture sample. I think that'll work. Let's cargo run this. Right. This is not off though, like I kind of expected it to be. Which means that if it's not off and I'm only rendering the screen texture, am I passing the wrong texture in? Like that feels like I'm rendering to the wrong texture. So stencil is fine over there. I think I'm passing in, right? Draw a section texture. We've got the view depth, the section texture, the view target. We've got our into inner with section in the right spot, depth in the right spot, etc. Color attachments are getting passed into this render descriptor. So this is rendering correctly to that section texture, as far as I can tell, with depth. Right? So did I mess something up in post-process? Let's go for post-process system. And render pipeline, section texture view. This is the section texture, which we're throwing into a bind group. Post-process. Render pass color attachment. Post-process destination. I think we probably could use depth here, but we don't need to at the moment. Doesn't feel very informational. Full screen shader, primitive state. Random order due to multi-threading. Random order of what though? Normally the Bevy scheduler determines the order of start once, except when rebuilding. I don't think that's true, actually. I was talking to Alice at one point because I had that misconception too, in that systems couldn't swap at runtime, but they can. And I actually, after getting that information from Alice, who knows much better than I do, I built a little example and proved that it actually can. And basically, if one takes too much time or something like that, they can flip. Is there anything like Vulkan validation layers on Mac OS X? Maybe something is going really wrong. I don't think something's going like really wrong. I think this is still user error. I don't think this is Bevy issue. I don't think this is internal. Until I validate that I have actually upgraded correctly, this is still user error. So let's take that off of the camera. Yeah. So it is almost certainly a me problem, because if we take off the section texture prepass component from the camera, everything is fine. So it is user error, almost guaranteed. at this point. Which means that I did something wrong somewhere. I don't know where that is at the moment. And I don't know that I have the mental debugging capability right now in my head to trawl through everything right now without sitting down, making myself some tea or something. So we definitely have an issue. It is definitely, as I just confirmed, user error. So I made a mistake somewhere. The trying to think of what this could be. The section texture gets generated appropriately. So I'm hesitant to say that the issue would be in the actual section texture. So it's got to be in the post process. Or in the way the data is being set up. And even when the section texture doesn't have one of these elements in it, the effect still happens. So that means that I think if our post process is applied at all, that this happens. Is there a, here's our post process settings. So let's get rid of our post process settings. We proved that it doesn't happen with the sections prepass. Or without the sections prepass, sorry. So I think this is something wrong with the prepass currently. So the issue will be in lib.rs as far as I can tell. So camera, view entity, resolution override, color attachments, begin tracked render pass with these color attachments, which is just the section texture, as far as I'm aware. Set the viewport render. Is this something RenderDoc would help with? RenderDoc, absolutely. Unfortunately, I don't have access to RenderDoc, but we would theoretically have access to Xcode. I haven't opened Xcode, I think, since the last time I did a small update on my computer, so I'm not sure that it will actually open. But since people are curious, I will break it out. And not schemes, I need the build stuff. So we've got an environment variable here called Bevy asset root. Bevy asset, I'm not going to be able to make Xcode bigger, sorry. But this is going to be this directory. So I'm going to just copy that to my clipboard and drop that over here. So this is the Bevy asset root, which is the root of the project in total. I think that this has to be in the example, actually. So this actually has to be here, not assets. So it's up to, but not including the assets directory. And then where is our Don't use custom working directory. This is me looking at the compute mesh. Let's go for GitHub. Rust Adventure. I don't know why I order this in by time order. I need to revert that. Bevy examples, edge detection. No, target. Where's target? There's target. Debug examples, edge detection, custom phase. Okay. Close. Now we run. We hope that this is set up correctly. Try not to type my password in on stream, and then it'll run. So here is stuff and things, right? I'm just going to move that over to my other monitor so I can actually click in Xcode. In debug, we're going to capture GPU workload, which is going to freeze the application while it looks like this. And after we've captured debug or captured GPU workload, we have a whole ton of GPU stuff on the left with all the labels. This is why you label stuff when you're working with WGPU, because the labels show up here. And if the labels aren't here, then you end up with a bunch of stuff that is not named well enough for you to actually like work with it. So here's our section pass, which is currently running, right? The section pass, are we in this? Perfect. So this is going to be hard for other people to read. So here's where it's setting the label, setting cull mode, triangle fill mode, depth stencil state, vertex bytes, fragment buffer stuff, and then there's a draw command. First draw command is that huge cube in the back. Second draw command should be the cube on the left. Third draw command should be the next cube, and so on and so forth. These are draw indexed primitives. So you can see that they're not drawing like in order at the moment. I think the third one in actually doesn't. Yeah, so they're not drawing like in order per se, but they are all drawing to the screen. Except for the one on the right-hand side there that is not, I think that doesn't have the component on it as a test. So this is our section texture. And our section texture seems to be being produced correctly. And that is, if any of you can see this, it's called section pass in the code with that label. This is where it says section pass. Here's tone mapping. And here's main opaque pass 3D. That looks wild. Hang on. Let's try to open this. This is what's happening in our main pass right now. And you can see it like the draw indexed all looks like the same kind of thing. What is that? Right? Why is there green stuff in the depth buffer? What do you mean? The depth buffer is down here. Oh, the green stuff is the thing that's currently rendering. Sorry. I see what you mean. The thing that's highlighted is the thing that just rendered. So I'm clicking around the draw index primitives, like WGPU stuff, right? So when I click to the next one, this is the next one that rendered. Click to the previous one, right? So if we zoom in here, you can see that it's not there. If I click to the next one, you can see that it's there. Why? Why there's a depth texture there, I am not certain. I didn't think we, oh, the pre-pass. The pre-pass probably created that. So in RenderDoc, we could step through the shader. I actually don't know how to do that offhand in Xcode. But for some reason, I wonder if there's an issue with the location of the custom pass. And I put it in pre-pass, and thus the depth texture is getting written and then used to create the other stuff in the pre-passes. And then they're conflicting in some weird way. We're in lib here, right? Depth right enabled true. Maybe I should have that at false. Hmm. The one thing that I want to check is actually, again, the ordering here. Are we already looking at that? No, it's all the way at the top. The draw section texture. Why is this in main pass? I'm gonna take a gander at what this looks like if I put it in pre-pass. Definitely the same issue. Shouldn't it be before the depth pre-pass, after, not before? Shouldn't it be after the depth pre-pass? I am kind of just experimenting at the moment. I am not especially, so I know that this code, or like whatever's happening, is partially related to the sections pre-pass, because when we remove sections pre-pass, it doesn't happen. When we remove the post process and leave sections pre-pass, it is happening. So we've got some information. I just re-enabled the post process. Right, so in main pass, it's flickering. Right? In pre-pass, I think it's not flickering, but still has the issue. Right? I think that the I think the depth here, this is something that didn't used to happen. Regardless of whether the outline was there or not, which means that the section texture is drawing, I think you're right. Let's do like after I don't know what this system is called. Let's do a search for on GitHub in the repo for Core 3D Systems free pass, which returns nothing. So I must have misspelt something. No, this is the wrong repo. Core 3D Systems free pass. Okay. So we've got our system sets. And I need to find the system that is responsible for that pre-pass texture. Early pre-pass, late pre-pass. Let's just pick one of these. It doesn't really matter which one per se. I'm going to qualify this in here, I think, if I can. Does this not exist? Hang on. Bevy core pipeline. This is not public. Okay, we can't order next to this. One of these other ones public. I wonder if this is intentional or not. Hub late deferred. And the other one was copy lighting information or something. Copy deferred lighting ID. This one's public. So if we run this after the depth, thick. I um you know what's really curious to me, actually, is that that is all of the meshes that are green, but not the one in the back. I feel like that's really interesting to me. Every back graphics bug is a potentially cool cliff action. Actually, I do. This is a fun. Like, if I had intended to do this, I would have been kind of happy with this result. I'm still kind of happy with this result, but it is absolutely not what I was going for. However, graphics APIs do be very performant, though. Massively cool loading screen. Yeah, I mean, like, I'm not mad at the effect. I just was not trying to get this to happen. You know? I'll save that for later. Let's sneeze my brains out. Okay. I think that I am going to have to debug this. Hopefully that didn't cause epilepsy, Xavier. It wasn't like a huge flashing screen, so I didn't think that that was going to be the case, but hopefully that did not cause anybody any issues. Thanks, Vic. I am a little bit confused here. That means the transforms are getting mismatched with the actual meshes, right? Yeah, I don't think that's the kind of flashing that would cause that, Xavier, but I'm not an expert, so yeah, so the locations of those meshes and the I wonder if that's something I should bring up to Charlotte or not. I mean, I'll mention it either way, but let me take a brief screenshot of the code as it existed to cause that. So this is still problematic, but I'm at this point kind of not sure exactly what the issue is. If we're in main pass, we're running after depth has been created. We're running after all the other pre-passes. We're running. It shouldn't matter when we run in main pass. I don't think. I guess technically speaking, we could run in post process, but after or before. Actually, can I order in between these? Is that going to be fine? Is it going to be after, before? Right, so after everything in main is done and before post process is apparently the right place. I'm still confused as to what exactly the ordering issue was. What it does seem to be as simple as long as this runs in the right spot, everything is fine. In my head, the dependencies that this has are we have to have all of the meshes pulled into the render world. We have to have the mesh data, their locations, stuff like that. We have to have the section texture IDs, which should have happened in the extraction phase already. We have to have the depth texture We don't have to have the depth texture, strictly speaking. We can have any depth texture because the section texture itself doesn't interact in that way, but I guess it might. Yeah. You know what? The outline is flickering on stream, actually. I'm actually, like, I just looked over at OBS. The outline is flickering on OBS. It's not flickering on my monitor. So if you see a big flicker on that rectangle, that is OBS causing that for some reason. I'm really not sure. That's really wild. Is that what y'all are seeing? Are you seeing like the back long rectangle have like long flashing horizontal lines? Like, don't get me wrong, this is not like a perfect outline solution by any means. Like, for example, even though these three shapes here don't have outlines, even because the thing behind it does, they still like get an outline drawn against that shape, which is not necessarily, it's an effect. Whether it is the right effect or not is not really, it's like up to the project kind of. Okay, so it still does it. That's wild. Okay, so if you're seeing flashing on stream for the outlines, it is just not, it is legitimately not happening on the actual monitor. I don't know why that's happening. Could somebody in chat like tell me how bad the flickering is, I guess? The shapes that are always outlined are also getting double, yes, because the outline draws on each shape. So it draws half on one, half on the other. That is a known issue. I haven't decided if I'm going to fix that or not. Really, I think what I want to do longer term is do a set of different outline implementations and make a video on it, which means that I actually have to do a jump flood outline implementation. As well as, this is a Sobel filter with a section texture and a post process. But we can do these in kind of other ways as well too, right? Like these two squares on the left, the benefit of this technique is that you get artist-driven outline locations. But the outlines are interior outlines, right? So half of the outline will be drawn on the current shape, and half of the outline will be drawn on the other shape, right? At least that's what I think is happening. I haven't verified that at the moment, but that's how it works in my head. Which means that it is like, is it a true outline if they're interior outlines? Not really. I guess like there are multiple kinds of outlines, right? Like you can put an outline on the interior, you can put an outline on the exterior, you can put an outline on the edge. And what this is doing is putting them like on the interior of the border of the change in color. So I could change that. I just haven't. But that is definitely a known feature of the system and not like a rendering bug. That That said, I think we have fixed everything that we needed to fix. I would like to go back and understand exactly what's happening with the other things. Um, Especially how we ended up getting like meshes rendering in different locations repeatedly. But I think that'll have to be a different effort. So I'm generally happy with this. We got the example updated. Render systems is very cool. I'm very happy actually in general with the experience of using render systems as opposed to the render graph. Everything I've converted so far has been it's been more pleasant to write with the render systems implementation. Feel free to ask a completely unrelated question on buffers. Yes. It looked like just the outlines that got rendered in the wrong locations, weirdly. Just the outlines got rendered in the wrong locations. Um, I don't think so. I think they're in the right locations for what the code is doing. But I definitely I acknowledge that the outline display is not necessarily like a top tier outline, if that makes sense. Like quality wise, I think there's work to do on the quality of the outlines. Um, but the example here wasn't really like, here's how to make a good outline. Oh, you meant the glitched output. Okay, yeah, I see. Um, I'm curious about the unrelated question on buffers. You need a big buffer for sorting on a compute shader, and you don't care about getting the data back to CPU land. However, you suspect the buffer was getting sent back to CPU on every frame. Do you have render world enabled on the buffer, or are you creating it in the GPU? Is it possible to create a buffer that only lives on the GPU and doesn't get sent back to the CPU? Absolutely, 100%. There's two things. Render world, render asset usages generally for stuff and things. Um, if this has render world, main world, things get kept in main world. The other thing is you can look into the WGPU stuff and start creating buffers. I don't know how you said compute shader, right? Yeah, big buffer for sorting on a compute shader. Yeah, so you're going to use the WGPU APIs to create a buffer and then just like keep that around, basically. Um, there are various examples in the shader advanced stuff. I don't know that I can think of one off the top of my head that explicitly creates a WGPU buffer. I know that the whatchamacallit, the game of life uses a texture and renders that texture, which is kind of like the opposite. The compute mesh example tries to use a mesh that is, I believe I labeled the mesh in the compute shader render world, but then it's like created on the CPU, uploaded to GPU, and meshes aren't really what you want. I can't think of an example that we have that actually just creates the buffer. So you're going to have to look at the APIs, I think. But you can absolutely do it, yes. You missed the Xcode debugging? Yes, the Xcode debugging is over. Texture binding array. Yeah, I don't know that we have one here. Compute mesh creates it doesn't create a buffer. I guess it does do uniform. See, what is a write buffer? Like this shows how to write buffer. I don't think that's entirely what they mean though. I think they want something more like a storage buffer. But in any case, Andres, you can definitely do that 100%. The compute mesh example creates a mesh on the CPU, uploads it to the GPU without readback, but is not created on the GPU to start with, so does not fit the qualifications they're looking for. Annoying IRL things you got to do, like eating dinner, keep you from graphics. Storage buffer without CPU access flags. I mean, that sounds right. But I don't have an example to point you to, right? Like, I feel like we should have an example of this somewhere. But there's a couple of different options here and stuff. What ended up being up the issue, assuming you solved it? The issue was specifically system ordering. I hesitate to say that was the issue because I don't understand why the dependencies needed to be ordered in this way. Like on some level, sure, creating the section texture between the main pass and the post process means that basically everything has been done before we generate that texture and then do the post process. But I don't feel like this is necessary. But it did feel like things were colliding in a weird way. So I don't have the answer as I would consider it the answer. What I have is a fix that is reasonably like this works, and I understand at a high level why this works, but I don't have the answer actually. Like I don't know specifically what was going wrong. I think it was an ordering / dependency related issue, but I don't know. There were some really weird. I don't know if you probably weren't around for the dance party, is what I'll call it. This. This is what happened when we ordered it in the pre-pass and after the pre-pass depth texture got written. So there are things that I don't currently understand about why this happened specifically. You'll notice that the blackened areas, the blackened triangles still exist here. I'm not entirely sure why those happened. They aren't actually triangles, right? As evidenced by like the tetrahedron over here on the right, for example, or whatnot. Yeah, anyway. The Bevy example, you feel like the Bevy examples are simultaneously overcomplicated and undercomplicated? Yes. I think that there's a couple of reasons for that. One of them that I can think of off the top of my head is that some of them act as feature demos and not examples. So they pack a lot of things in, but you can't just go to that example and copy paste something out easily. There are API demos, which are pretty good, but those tend to be a little bit simpler. There's a use cases category that hasn't really been filled out all that much yet. You're saying Bevy example so show some really complex things and at the same time failed to show like a list of the common ways of using something. I think that is book material, not example material. Honestly. What do you mean the render graph is gone? That's the entire stream. There's no announcement yet because it's a 0.19 thing, so there will be an announcement with the release, basically. But a PR got merged. It's called Render Systems, or replace render graph with render systems was what it was called. $22,144 removes the render graph in favor of using schedule. Sam, you tried to get into Bevy recently. You couldn't get a good grasp on integration between different things. Example, real world implementations of main menu versus game state. There's a main menu example in the repo that uses game state. Yeah, the book, at some point, I believe the book is just going to get like a, hey, this has to ship, and it'll get shipped. It is in the repo. It was always merged. There's no like PR for the new book. It's like just getting PRs. You just somewhat understood some shader stuff in Bevy. Hopefully this new thing is better. I think it's good. I think it's a good change. Yeah. I don't know how much impact it'll have on people, but it's definitely like we go from having a render graph to whatchamacallit, to just using the schedule system. So if you understand how schedules work and systems work and dependency injection stuff, then you can work with like systems in the render world a little bit easier. You recall a big PR, maybe right after Rust Week last year. But the book is just sitting in the repo. Like this is all the content. Somebody just updated it, you know? I think that writing is not the same skill as writing code, is not the same skill as reviewing, etc. I have a tough time contributing to the book specifically because the way that I make money and funding and are able to do videos like this, like the stream we're on right now, is because of Rust Adventure. And if I'm writing tens of thousands of words of like how things work and how to do things, it's hard for me to do that in a place where I'm not increasing the level of funding that I have to do more of it. So I don't know. It's tough for me to like say that I would write, because for example, I wrote Flappy Bird recently. Flappy Bird is about 10,000 lines or 10,000 lines, 10,000 words for one workshop. And writing that much and then just not being able to use that to fund the next one is really tough. And I think that combines more generally for other people too, right? But that combines with like the book then only gets work by people who are able to work on it for free, who are not otherwise doing PRs to the Bevy repo, etc. Right? Which is tough. So my guess is that this pops up again at Rust Week. It has another push and maybe gets shipped or something. But you have a hard time contributing because the things you want to contribute are 10 non-existent chapters deep, so would not fit in anywhere. That's an interesting thought. Could you give me an example? Or like, the way I would frame it is, has anybody told you that that is not a thing that would be accepted? Right? Are there things that you really want to write about that you think are being, like, has it actually been rejected? Have you been like, hey, I want to write this chapter. I just want to know that if I write this chapter, if it's relevant for book, if it's like, you know, even has a possibility of being merged or not. I'm sure that if you said that to like Alice or somebody, they would be able to be like, yeah, we would have a chapter on that or no. And I think not writing chapters because there is other content that doesn't exist doesn't really make sense. So unless you were told no by like Alice or somebody, I would suggest that if you want to write, there is a lack of people who want to write, and that you should at least propose writing it if you want to do it. Honestly, with like menu versus game state, the states examples are pretty complete. There's also a certain level of it really is that simple. Yeah, I actually think the menu example is fine. Like there's states and there's menus and it works. Right? I don't want to like trivialize people's difficulty with the examples and whatnot. I think they can always be better. But yeah. You did see the state examples, but trying to implement a bigger game in the same way felt too clunky because defining what belongs in which state felt too explicit for your non-ECS brain. Felt too explicit for your non-ECS brain. So you're having trouble with like modeling an entire game. Like, how would you sensibly contribute a list of short, useful snippets, like what we were talking about regarding ways to use shaders in a GPU in a book that hasn't even gotten to render anything yet? If they're short, useful snippets, then I think those go into the examples, actually. Right? Like, we don't have examples for example, we were talking about render stuff, right? So if you go into the shader advanced or whatever, there's no like real documentation for like how do you create and use a storage buffer, right? So I think that just goes into that examples directory. You're not the most experienced, but don't you basically just need to draw out a state machine with the expected states? Like anytime you say, don't you just need to, is probably wrong. But generally speaking, I think if you are thinking of states and you're thinking of main menus and playing and stuff, the menu example that is in here is actually fine. Right? Like this literally shows a menu and shows how to handle entering, leaving, like how do you schedule things when enter and leaving, etc. I don't know exactly what they meant by Needing to specify everything in a state, defining what belongs to which state feels too explicit. I'm not really sure what that means, but um, like if you have a main menu, then it makes sense to spawn the main menu when you enter, operate on it when you're in that state, and despawn it when you exit. Like that makes sense to me. So in Godot, everything takes place in scenes, and nodes implicitly belong to those scenes. So when you switch scenes, everything gets swept away, and you don't have to say this belongs to the menu. Sure. So what would you do if your menu was an overlay over the, like, what do you do for a pause menu? You just make a second scene, or is it part of the same scene? And I think you're saying like you don't have to say this belongs to the menu, but you are saying this belongs to the menu if you're using a menu scene, right? Like if you say that everything in this scene belongs to the menu, you are defining that everything in this scene belongs to the menu. Like you've already done that. So it's the same thing. Honestly, there's one issue in the states example: manually despawn and on exit cleanup instead of despawn on exit. Yeah, that can be fixed. Yes, this is inserted as a resource. I think this was written before state scoped existed. So I think this resource doesn't even need to exist, actually. That could get removed. The things of world, seeing groups, collections, bugs your brain, it's all the same to you. Yeah. I think that, yeah. I mean, they're just collections of stuff, right? In your experience with the Godot, a pause menu is usually part of the game scene, often a prefab with UI nodes that got disabled in some way when they're not needed, i.e., the game is unpaused. Yeah, so that's just a pause substate, right? Like, in the same way that you have states, you can have substates, or you could do it at the top level with like is paused, right? This one has it has a substate, but fine. So like when you're in playing or whatever, you have some state that represents whether you're paused or not. When you pause, that menu gets spawned. While you're in pause, the pause system, the pause menu systems are running, and then when it's unpaused, those get cleaned up. That's like it's not that different, I guess. Um, like I guess you just implicitly like disable and enable the pause menu in Godot is what it sounds like, with the example that you gave. But I don't think that it's that far off from what you're talking about. Yeah, I don't think you're saying one or the other is better or whatever. I am just I'm trying to draw connections more than I'm trying to say like this is good or that's bad, you know? More intermediate size projects would absolutely be useful for sure. You just showed up, so maybe you're missing some context, but if you need ideas for the book, you'd find a reference for Bevy's WGSL imports super helpful. The file names don't line up with the, I assume that's a character limit. The file names don't line up with the export paths. Yes, they do. The file names absolutely do line up with the export paths. Right? Bevy PBR, source, render, fog.wgsl. I guess that is Bevy PBR fog. That is weird. The other ones that I'm used to using are more direct. Where is ambient light? What do you mean, like, where is ambient light? like, what are you looking for related to the ambient light? Could it be in PBR ambient? I would say that that's not a book thing, though. That is a documentation. You said, but that is different from where you get the rest of the lights. I think you're just saying that there are files that are imported from each other at this point, right? Like if you, here's mesh view binding lights. Right? There are multiple files. And that is definitely going to be a thing. The these paths and imports and stuff, really the solution is I'm not going to be able to pull this up because it's not in my history at the moment. But there's a tool called Weasel Docs that's mimicking Cargo Doc that is getting built, and will turn into something like this at this point, where you can find stuff like this. So you were just looking for ambient light. Hopefully this is, no, I don't think it has everything. But yeah. Your complaint is that there's a web of things to remember with little documentation about it. I hear you on the little documentation, but there's always a web of things. I think that there are not that many places that WGSL files exist. Bevy PBR render is one of them. Core pipeline is another. If you're looking for sprite rendering stuff, it's in sprite render, right? So I don't think that there are that many places for these things to exist. And there will always be files that import other files. And getting used to using things that can search through and find stuff in WGSL files is super useful, right? So like if I do ambient, I don't know if WGSL is built in here. Unrecognized file type. Right. I don't know if extension is here. E. I think E is exclude. I don't know how to use rip grep like that apparently. But like searching through these files with WGSL is fine. Oh, you're trying to come up with areas that could use attention. My bad. Oh, I thought you were having issues. No, yeah, there's like plenty of stuff to write in books and stuff. So like, I don't think, yeah. Yeah, that's Weasel Doc or the stuff Yannick 4 is working on. Indexing for documentation of shader code sounds like a godsend compared to every other shader language. Yeah. I think that the Weasel Doc stuff is going to be very cool. So my understanding is that this is mildly on pause until Bevy actually adopts Weasel, and some other things happen. But the idea is that this is cargo doc, but for shaders. So, you know, um, vertex output is a common one, right? Here's vertex output for a full screen. Not everything is on this, by the way. I'm looking at like a Weasel doc here. So, just to point out that this is not the full Bevy repo on this particular site. But we will be able to have like actual documentation for stuff at some point, fairly soon, actually, which is very exciting. But that's I think that's it for the stream. I'm gonna go make myself some tea, and take a little bit of a break. Thanks everyone for hanging out. Bevy Jam 7 is next week. 6 days, Friday. So we will be February 7th is Saturday, right? February 7th is Saturday. So for our Saturday stream, I will come online a little bit before the jam starts, and we'll have a stream kind of as the jam is revealed on Saturday. Hoping to have a couple of jam videos up before that for cool and useful crates and stuff. We'll see if I can get those out or not. But yeah. If you haven't joined the jam, join the jam, and I will see you this weekend. Later.